All right, this is the Foundations of Mathematics and Pre-Calculus 10 sample questions for practicing electronic tools. Now, you might be saying to yourself, electronic tools, what? Especially for my students, you are going to be taking, at least for this year, a paper exam. And so some students around the province are going to be taking an e-exam, online exam. And so as a result, they've created some questions here for students to kind of get used to how that's going to look on a computer screen using the various electronic tools like they're going to have. The good news is that we can still answer these questions without using most of those tools. There's only one or two questions where there's some issues. So the way I look at it, it's just some more questions for us to practice. So let's take a look at some. So number one, the function y minus 3 equals 2/5 onto x plus 1 will go through which point on the following graph? So notice that this is in slope point form. So we know that it's already going to go through the point -1 and 3. So I would start with that point, the point -1, 3 being right here, okay, and then apply the slope from there. So slope's going to go up 2 over 1, 2, 3, 4, 5, up 2 over 1, 2, 3, 4, 5, and bingo, we have our winner, and we have a line that looks something like so. Okay, so that one would be A. Number two, James correctly graphed y equals 1/3 x plus 7. Note this graph is provided for rough work, so let's forget what the students' answers are down there. Let's just graph it ourselves and see what happens. So we'd have a y-intercept up here at 7. So this is in slope intercept form. And then we have a slope of 1/3, so we go up 1 over 3, up 1 over 3. And we roughly, you'll be able to use a ruler on your test, but you get something that looks like so. And let's see which one that makes it look like. I'm thinking it looks like C. All right, good. Okay, number 3. Which of the following coordinate pairs would be a possible point Q so that line CQ is perpendicular to AB? Well, my thought is, let's first figure out what the slope is of AB. So we'll do that over here on the left-hand side. The slope of AB, now you could use the equation if you want, but you're making your life more difficult than you need to be. Always move from left to right, so in this case you're going to have to go down 1, 2, 3, 4, 5, 6, and over 2. So remember, it's rise over run, but we sometimes like to think of it as fall if we're going down, so it would be fall over run. So we have -6 over 2, which ends up giving you -3. So if that slope of AB is -3, the perpendicular slope of this new line, CQ, that we're trying to roll with here, will be the negative reciprocal, which will be 1/3. So my thought is then if you stay here at C and you apply a slope of 1/3, so up 1 over 3, over 3, over 3, I'm hoping that one of these, that one of these points, over 3 down 1, like so, will match one of the multiple choice answers. So let's take a look here. The first one, what do we have here? We have -3, 3. -3, 3 doesn't look like that one works. -3, 0 doesn't look like that one works. 2 1's not looking too good. And the last one we have is 1, 2, 3, 4, and up 1, 2, 3, 4, 5. So we have a winner right there. And so your answer is D. Number 4 says a line segment has a slope of 1/5 and passes through point F. And then at the end here, if I scroll, it says, what are the coordinates of the x-intercept of this line? Well, we could see if we could graph it, and maybe that'll help. So if it has a slope of 1/5, that means we're going to go up 1, over 1, 2, 3, 4, 5, like so. We can go in the opposite direction, down 1, and over 1, 2, 3, 4, 5, and then down 1, 1, 2, 3, 4, 5. And so if we had to figure out what the x-intercept of the line segment would be, that looks like it's over at -11. And then you just have to remember how to do -11 with your ordered pair. Remember the x coordinate comes first, so that looks like it's going to be A. Now, number 5, how long is the fork below? Well, here's a problem. When I printed out this exam for you guys, the dimensions of this fork have been changed. And so I can't guarantee you that the answer is what it was supposed to be. And so if you're writing a digital exam, what would happen is, of course, it would be written to scale, and you'll take this little weird digital ruler and you'll kind of put it up to the fork, and you'll be able to interpret it what it was supposed to be. So number 5 was intended to be A, but because it's been kind of changed a little bit, it's not going to be that accurate. So for that purpose, we'll just kind of skip it. Number 6, a surveyor drew a scale diagram of a building. Unfortunately, his plans got water on them. Help the surveyor by figuring out the missing angle of elevation. So there's nothing too wild that you have to do here. You don't even need to consider either of these two dimensions. All we need to do is you just need to use a protractor. And so on this exam, you're going to be able to use a protractor. So if you have a protractor handy, you'll be able to find that that angle there is 35 degrees. Okay. So in class, if you need a hand on that, let me know. I got some protractors that you can play with. Okay. Number 7, which of the following triangular prisms have the same volume to the nearest cubic meter? Diagrams are drawn to scale. So they're basically just taking a look at these 3 diagrams here, and we're trying to figure out which ones have the same volume. So you'll notice that they've given you kind of information in all of them. The one kind of big piece of information is that they actually tell you what the volume is of this one right here, 255. So my thought here is that we have a little bit of a problem with what at least I've given you guys. The diagram that you have and the one that I even have on this page right now is not necessarily drawn to scale when it should be. So it may be a little bit larger, a little bit smaller, so that's problematic. As a result, what I thought I would do is I'd give you kind of a game plan, assuming that everything was to scale, as to how I would solve this. Okay. So my thought is I'm basically going to only deal with the diagram 1 and 3, and then I'll compare that to 2 to kind of see where we're all at here. So if you wanted to find the volume of this first figure, remember that volume is equal to the area of a triangle, which would be 1/2 base times height. And then you're going to take this and you're going to multiply it by this whole length, like so. So in order to do that, let's take a look. Do I have the length? Yeah, you got the length, so that guy's good to go right there. Do you have the height? Yeah, you know it's 3.5, that's good to go, but you don't have the base. Well, my thought is you take a protractor right here and get that angle right there, then you can just use SOHCAHTOA because you have the opposite side and you'd have the angle to figure out what this base side is. Once you have that base side, you can just multiply it by 2, and then you have the entire base. Put into that equation, then you should be able to find the volume of that. Okay, so hopefully that helps. Like I said, I'll skip the second one here. Let's see what we're looking at for the third one. So the third one, kind of similar to what we had before. My thought is right here is we need to, again, maybe I'll actually just write the equation. We have the volume is equal to the area of the triangle, so base times height, all multiplied by the length. We have the length. We have the base this time right there, so I'll put a check because you would just take this and double that. So in this case, what would we say that is? We'd say that's 15.6, like so. But we need to find the height. Well, I would use SOHCAHTOA again in terms of x. So I go and find out what x is, get that angle, and then you could use SOHCAHTOA to find the height here. Or I guess, what am I saying? You could just measure it to find out what the height is, and then just substitute in, and then you could compare the volumes, okay? So you might want to give that a try. I don't think it's going to work out too precisely for you, but the answer they were looking for anyways was A. All right, number 8, a company has created an inflatable building that resembles a cube. There you go. On their website, they advertise a 3,375 cubic foot building. George wants to know what the dimensions of the building are. What is its length to the nearest foot? So let's draw ourselves a little picture. So we have a cube. I'm a horrible drawer, but let's say something looks like that. We know all the dimensions are the same. Well, if you recall, if we know that this 3,375, that would be the volume of this building, so I can say that the volume is equal to 3,375. We know that to find the volume, if it's a cube, it must have been side, so this side, times this side, times this side, or side cubed. So side cubed would be equal to 3,375. And so now if you want to find out what the side length is, you will just take the cube root of everything. And so if you want to find the solution here, we'll take the cube root of the 3,375, and it actually is a perfect cube. You would be able to use a calculator for this one, and we find it is exactly 15 feet. Okay, number 9. Determine the perimeter of the shape below in inches. Here's another one that's a little bit problematic because, of course, it's not drawn to scale right here. What I'm going to do is I'll give you guys the correct answers, assuming that you can measure correctly. So what you would have found is you would have found that this dimension here is 1 and I think you would have found it to be 1 3/4 inches, and then on the other side here you might have found this one to be 1 7/8 of an inch. So why don't let's assume that you could get those two dimensions, and let's figure out how you'd add all these up, because that's kind of a little bit problematic here. So what you're going to have to do here, in my opinion, is change all of these to be improper fractions. So I'm going to kind of work our way around. So let's start with the this one right here. The 1 3/8 is the same thing as you writing this as you go 8 times 1 is 8 plus 3 is 11/8. So we've dealt with that one. That one's check. We'll go deal with this next one. So 1 3/4 is the same thing as you going 4 times 1 plus 3 is 7/4. And then we'll deal with the 1/2 an inch is just good to go. So we can put a check on that one. And then the next one, we have 8 times 1 plus 7 is 15/8. So these are all in terms of inches. Now what I'm going to do is I'm going to try to achieve a common denominator. The common denominator that I'm going to change everything to is going to be out of 8. Now notice that those two are already out of 8, so we're good to go. What do you multiply the denominator by with this 4 to give you 8? It would be a 2, so we have 14. This one you have to multiply by 4, so you have 4 eighths. And now I'm just going to add everything together. Now notice, because you have a common denominator, the denominator stays the same. 11 and 14 is 25. 25 and the 15 is 40. And add the 4, you have 44 over 8. Now, since these are all in terms, if you look over here in 1/8 of an inches, or at least those ones, I'm going to try to see if maybe we can answer in 1/8 of an inch. So let's see, how many times does 8 go into this? Well, 8 goes into 45 times. And there would be how many remainers? Well, you'd have 4/8 remaining. And so what do we know about 5 and 4/8 inches? Well, 4/8 of course can be reduced, so we know that this is equal to 5 and 1/2 inches, which is B. Number 10, the final question in this section. Determine the lateral surface area, so remember that's just the surface area going around, not the base, of a right cone with a height of 5.5 centimeters. So that's meaning the height is going right from the middle is 5.5, like so. All right. So what are you going to have to do this? Well, we have the surface area, if you want, of the lateral area for this is just pi times the radius squared. And so what they assumed that you could do here, folks, is that you could measure this thing by hand. There's no real other way that you could get the radius. So I'm just going to give it to you, and then maybe you could work from there if that helps at all. The radius, we're going to say, I think the entire diameter ended up being 4.2. So let's make this 2.1, and then we'll go from there. So we'd have pi, and then you have your radius 2.1, and then you need to have the slant. But we don't have the slant, so you got to do a little bit of work. We know this is a right angle. We're trying to find this s over here. So I will use myself Pythagoras. We have s squared is equal to 2.1 squared, that's my radius, plus my height, which is 5.5 squared. Okay, and when you put all of those into your calculator, you should get 34.66. That's equal to s squared. And when you take the square root of everything, you end up getting that s is equal to approximately 5.887. And so now I can substitute that into this mysterious s that I had. I have the 5.887 like so, and if you crunch those numbers into your calculator, you get approximately 13.8. And because they've rounded to the nearest, what do we got here, nearest centimeter, it looks like we can say that this is approximately 39 centimeters, which would be B. Okay. That concludes this fourth and final section. My apologies, this one was a little bit weird, but the problem is, again, is if I photocopied this, it's changed kind of the dimensions, and the diagrams not necessarily are to scale. Okay, so if your answers when you originally did it were a little bit off, this might be why. Thanks.